Hello, welcome all to Science Simplified Session 3. We learned about gravitational law and its effect as weight on the mass. Weight is nothing but the force of gravity exerted on the object. Since this force is always attractive, it holds all the object to the earth. First artificial satellite, Sputnik 1, was launched by Soviet Union on October 4, 1957. It was the size of a basketball, weighing about 183 pounds, and was orbiting Earth in 98 minutes. It worked for 3 weeks before its batteries died down. Traveling into the space. In this episode, we will now learn how to escape the gravitational force of the Earth so that we can launch the satellites, we can go into the space. Okay. In this animation, we see a space shuttle being launched. There are rockets which gives velocity to the spaceship, and then it goes into the space, escaping the clutches of gravitational force of the earth. So we are going to understand now how to escape the earth's gravitation. Escape velocity. Let us understand the concept of escape velocity. For that, let us do one thought experiment of firing a cannonball. As shown in this picture, if you fire a cannon, then the cannonball comes down and falls at point A. If you increase the speed of the cannonball further, then it will go a little longer distance and fall at B. We further increase the speed of the cannonball, and now the cannonball, when comes down, the earth also curves away at the same rate, and that is how this cannonball goes around the earth without touching the earth and completes the orbit, coming back to the same starting point. Further, we increase the speed of the cannonball, then the orbit of this cannonball is little away from the earlier object in a elliptical path, and still it comes back to the original point. We increase the speed further, and as shown in E, the ball escapes the gravitational force of the earth. Now you know, in case of a freely falling object, the distance traveled is given by half into g into t square. Here, g is the acceleration due to gravity. For simplicity purpose, let us assume the value of g as 10 meters per second square. Then we find that in 1 second, a freely falling object will fall through 5 meters. If we now consider this cage showing the earth curvature, then if we throw a ball at 8 kilometer per second velocity, then in 1 second the ball will come down by 5 meter and touch the earth. Let us understand this further with some calculations. Here we have shown earth not to scale. Distance AB as 8 kilometer and radius of earth as 6,371 kilometer. If we now use the Pythagorean as OA square plus AB square equal to OB square. As per this Pythagoras theorem, if we substitute these values as shown here, then we get OB as 6,371.005 kilometers, or we get distance BS as 5 meters. So this is the distance a ball will fall through after traveling 8 kilometers in 1 second. So if we keep a ball at point A and throw it at 8 kilometer per second, then in 1 second it will reach point S. But if the ball has 8 kilometer per second as a velocity, then by the time ball reaches point S, it gets a boost of another 8 kilometer per second, and it will go further, then come down at this point. So this is how the ball will go on traveling around the earth, because the amount by which the ball comes towards the earth also curves away from the ball at the same rate. So if the ball is thrown with 8 kilometer per second, it will not touch the earth. As shown in this diagram, it will go around the earth but will never touch the earth. We can see this pictorially in these 4 diagrams. Here the ball is traveling less than 8 kilometer per second, it touches the earth. The ball is traveling at 8 kilometer per second, then it will go around the earth. If the speed is greater than 8 kilometer per second but less than 11.2 kilometer per second, then the ball will travel in an elliptical orbit, and when the speed is greater than 11.2 kilometers per second, then the ball will never return to earth but escape from the earth's gravitation. Now let us understand how do we get this velocity as 11.2 kilometers per second so that it escapes from the gravitational field of the earth. So what is escape velocity? It is the minimum velocity an object must have in order to escape the gravitational field of the earth. That is, escape the earth without ever falling back. The object must have greater energy than its gravitational binding energy to escape the Earth's gravitational field. As we have seen earlier, all the masses are attracted towards the Earth because of the gravitational force, and all the masses are held down on the Earth because of this gravitational force. So, they are bound by the potential energy to the surface of the earth. Now, this potential energy is given by mgh, where m is the mass of an object, g is the acceleration due to gravity, h is the height from the center of the earth, which is at the surface, equal to r. So we can say the potential energy or binding energy on the surface of the earth is given by mgr. Now, if we are to escape overcome this potential energy, then we must add the kinetic energy, which is more than the potential energy. This is what initially we saw. A rocket is fired to take the spaceship away from the Earth. So let us now calculate. We have to make kinetic energy equal to potential energy, and then we know the by the formula half mv square, which is kinetic energy, is equal to mgr. So equating these two and removing mass from here, we get v square equal to 2gr. You will now recall this small g, that is acceleration due to gravity, is given by capital G, a universal constant, into mass of the earth divided by r square, and we get the equation as v square is equal to 2gm by, or we can now say the escape velocity Ve is equal to square root of 2gm by r. So this is how we can calculate the escape velocity as far as the earth is concerned. So escape velocity from the surface of the earth, we have seen, is given by this. Now you can observe here that the direction of escaping velocity is not important. As long as a body gains this much of kinetic energy or this much of velocity given by this formula, it will always escape from the Earth's gravitational field. So these are the two equations we get for the escape velocity from the Earth. Here we can now substitute the values as small g as 9.81 meters per second square, radius of the Earth 6,371 kilometers. Then we get escape velocity from the Earth is 11.18 kilometers per second. Now you can correlate this with the earlier slide where we have shown that 11.2 kilometers per second velocity, an object will escape the gravitation of Earth. We can use this general formula as escape velocity from any planet is equal to square root of 2g into mass of the planet divided by radius of the planet. Now let us calculate escape velocity of the sun. Now this we will calculate with respect to Earth. So Earth is traveling around the sun at a distance r. So at this distance r, knowing the values of mass of the sun, the distance between sun and the earth, and the gravitational constant, escape velocity of sun will be 42.1 kilometers per second at a distance equivalent to the distance between the earth and the sun. Now what velocity does the earth have? So let us calculate that. That earth travels around the sun in 365 days, and the distance traveled is equal to the circumference of the earth orbit, which you can calculate as 2 pi r, and here r is 150 million kilometers. You can substitute these values, then we get the speed of the earth as 29.8 kilometers per second. So obviously the speed of the earth is much less than the escape velocity of the sun. So earth will never go away from the sun's gravitational field, and that is why we are safe. Using the same formula, we can now calculate the escape velocity of all the planets in the solar system. And here we know that Earth's escape velocity is 11.2 kilometers per second. Jupiter has a highest escape velocity because of its mass and the radius as 59.5 kilometers per second. And as shown in this animation, the velocity at the Jupiter has to be so high that we even don't see the rocket leaving the Jupiter's surface. With this, I hope you are now clear about the escape velocity from the planets and how it is calculated based on the Newton's law of gravitation. Thank you. You can always contact me on email or you can watch YouTube channel as given here. And thank you once again. We will meet next time with few other concepts. Thank you.